Okay. We are streaming over. There we go. Good, good. We're streaming over on Twitch. Just pulling up all my monitors here. Okay. We're streaming over on Twitch. Just pulling up all my. All right. So it looks like we have everything all up and running. So hello, everybody. Today is August 13th, 2026. August 13th, 2026. It is currently almost 10 o'clock in the morning here. 9:58 to be exact. And what is this stream today? So the stream is the process of copywork and review of review of Augustus De Morgan's Elements of Arithmetic. Augustus De Morgan's um, Elements of Arithmetic. So this book was first published in 1830, and yet it still holds true to today. It is an excellent work, very, very insightful, and definitely forward-looking as far as textbooks go, in that he is preparing the students for the continuation of their studies, moving from arithmetic on to algebra. So, I have already, in previous streams, I have already gone over section 1. So today we will begin section 2, and my streams normally last around 3 hours. This is a study stream, and this is the process of acquiring skills in a number of different areas, all of them more academic in their outlook. And so what do I mean by that? I mean that in that everything that we do, every skill that we encounter, or every profession that we have, we must engage in a particular set of skills, in a particular set of core skills. And in my instance, because I am taking on the profession of a teacher, or of an academic, or I should say, to be a teacher is a subset of academia, then my particular domain is knowledge work. You'll have to forgive the direction, or the change in direction in the flow here. So that I am engaged in knowledge work. Okay? Now, what does that mean? That means that I have 3 skills that I'm responsible for. I'm responsible for acquisition, I'm responsible for the categorization, and I'm responsible for the recall of knowledge. I must acquire knowledge, my job is to categorize knowledge, and then my job is to recall knowledge. So the purpose of these streams is such an exploration and such a process, in that the acquisition is the actual reading of the textbook, and in this case, the copywork. Now you'll notice that the copywork is going to be in what is known as Gregg Shorthand. And what that is it's a style of handwriting that allows you to, and hold on, let me go write that out here. So shorthand. Shorthand. All right. So in shorthand, we are responsible, or we attempt to capture the sounds of speech in the smallest amount of effort possible. So you really focus on focusing on frequent words, so on and so forth. And with that being said, this is what the purpose of the stream is about. Any links, if you're interested in any sort of follow-up links, a link to the textbook, for instance, that is down below in the description. There's a link to follow-up resources regarding shorthand. The dictionary that I use is also down there, and any of the apps that I use for my display or for my content preview is also listed down below. So let's go ahead and get started. This is a pure copywork stream. So what I do is everything that is listed over in the textbook, I simply display over in the on the page, or I should say in the notebook, and I display it in the notebook, but it will be in Gregg shorthand format. Okay, so let's go ahead and get started. We start first with section 2. Now you'll notice that there are some words when I don't know what the word means, or when I don't know what the particular form of the word is, then I look it up in the dictionary, which is also listed down below. So you'll see me accessing all 3 pages as we go forward. And if there are words that are not in the dictionary, then I note them off to one side on a piece of paper and then follow up and add them to the dictionary at a later time. All right, let's go ahead and begin. So we start first with our title, which is section 2, and we're going to go ahead and do that right here. So we start section 2, and let's see, that one's going to be section 2, like so. Let me go ahead and confirm that that is section in the dictionary. And yes, that is indeed. Now you'll notice that the dictionary appears to be swapped in its orientation, and that is completely deliberate. The reason for that is because I write Gregg shorthand in mirrored format because I'm left-handed, and when you are left-handed, it is easier for you to write, or it's more appropriate for you to write Gregg shorthand starting on the right-hand side of the page and then going across to the left versus the normal direction, which would be from here. So this for me, even though it's mirrored, so for you it's mirrored, but this for me is the right-hand side. This is the right-hand side, okay? And this is the left-hand side. All right? Now for you, you see it as reversed. You're seeing the reversed view, okay? So just wanted to clear up the air in case anyone has any questions. Not that anyone has up to this point, but I do write everything reversed. And it looks like we dropped, I must have dropped connectivity. We back in. We look good now, huh? Okay, good. So, as I said, I write everything reversed, and so therefore you'll see some funny changes every once in a while. Okay, so let's go ahead and get started. So this is section 2. And the particular title here is addition and subtraction. Addition and subtraction. This mark right here is called a paragraph marker in Gregg shorthand. And now we do addition and subtraction. So let's go ahead and get started with that. Looks like we're having some more connectivity issues. Is that the problem on my end? No, might just be my display. There we go. All right, so let's go. Addition and subtraction is the title. So addition is going to be addition and subtraction. And subtraction is going to be this traction. I'm going to guess at traction, and we'll see if that is traction. Okay, so we go over here, we go subtraction, we look up to see if that's the word, and indeed that is the word. Notice once again, it is reversed for you guys, but just know that you can write Gregg both ways and it's perfectly fine. You can write English reversed as well if you so intended. I know that Leonardo da Vinci, for instance, wrote some of his textbooks or his notebooks are written in mirrored format. him being left-handed. Now, of course, I don't go that far with my normal flow of text. I'm perfectly fine writing in the correct orientation, but for Gregg's shorthand, where it's really something that's only useful for me to study and for me to be aware of, then I do take the opportunity to put it in the correct orientation. All right. So we have section 2, addition and subtraction. Go ahead and check. Need to check this here. Addition. Yep, and that is addition. Very good. So we're set, ready to go. Next paragraph. And this is number 28. This is paragraph 28. Now, if you do come in from another stream and you see what I'm doing here, then you'll notice that I had said that I was going to try and balance out my shorthand, but to be honest, I was giving it some more thought last night, and I was thinking to myself, you know, I'm just barely starting out in shorthand, and so therefore I really should focus my attention on learning the skill well, okay? So I am going to devote some more time. Obviously, I am spending most of my time with the textbooks from my chosen profession, which is going to be mathematics. And so therefore, my mind will already be working in the domain of mathematics, but I will be spending a little bit more time on shorthand. I felt that I wasn't giving it its just desserts. So let's go ahead and get started. I've already begun here. Now I'm curious if I do highlighter, I'm curious what that looks like on stream. Okay, good. Yeah, it's kind of a greenish color, which is very nice. All right, so let's go ahead and get started. Here we are. So we have there is no, let's see, there is, here we go, there is no process, and process, it requires just a little bit more of a curve. So let's check that out here. Scroll back up. Yep, and there's process. There is no process in arithmetic. That, or which does not consist, and consist is, see if I can remember, I think it's con SS, or maybe it's a backwards S for consist. Let's see. Let's check consist. Scroll up. Yes, it is. So it's a uses a backwards S. So there are two S's put here in order to show consist. There we go. Which does not consist, and then entirely in the increase or diminution of numbers. So we need entirely. You know, I don't think, I can't remember entirely, so let's go ahead and check that out. Entire, and then if we use entire, then we just put entirely on it, and that is correct. So we go entirely, so we go en, and then our diphthong here, and then we do a circle inside. There we go, entirely. There is no process in arithmetic which does not consist entirely in the, and then in the increase or diminution. Diminution, now that's a fun word. I'm going to guess that it's diminution, so I'm thinking that it's gonna start out with a DM stroke like this, and then maybe an E, U, shun. Eushin. Diminution. Let's see if that is anywhere close. Diminution. And of course, the word is in there because it's a This is an old dictionary, or I should say the words were derived from an old dictionary, so diminution. There we go. All right, so there is no, or diminution of, and then numbers. Numbers is going to be like that. So let's go ahead and check numbers. Over here. Yes, very good. Of numbers. That's the end of the sentence. We drop a little period marker. There is then nothing which might not be done, which might not be done with collections of pebbles. With, and then collections is collections, I believe. Let's see if that's a collection. Yes, good, good. So it's just collect, which is K-O-L, and then you add a shun ending to it. So, which might not be done with collections of pebbles. Pebbles is going to be P-E. I'm assuming that it's just really simple, which is, you know what's interesting is bowl, BL, can sometimes be shown with just a B. So it could be pebs. Let's go take a look. Hey, it's in the dictionary. Very nice. And yes, that is correct. So there's a very interesting phenomenon in Gregg shorthand that the BL ending, so rubble, pebble, stubble, enable, what would be some other ones? Um, I mean, there are so many. There are so many that I can't think of them. Anytime you add an A-B-L-E ending to a word, you can show it using the B. Just a B stroke by itself will show the bull ending, okay? So this is pebbles, pebbles, and do that here. Collections of pebbles, okay? Probably at first, and probably is it problem? I think it's just PRBE. Let's go check that out. And that is correct. Good. So probably, comma, at first, comma, either these or the fingers were used, and either is, I think isn't it a backwards turn? I think it's a backwards turn. So we go over here to either. Yes, good, good. Either these or the fingers were used. Either these or the, and then fingers. That's probably fingers, right? So we go down, and that should be finger right there, because it uses a downward slant for the NG sound. There we go. Back over here to the dictionary, finger. And that is correct, yes. Now, to make it plural, you simply change the circle to an oval. And the changing of a circle to an oval turns it into it will turn it into a pluralized, changes the R to an S. RS. All right, so now we go through. Probably at first, these are the fingers were used. Were. There we go. Used. Period. Our word calculation. Our word calculation. Calculation. I wonder, I've never checked this, but I wonder if the keystroke is calc. Let's go ahead and check. Probably not, because it's not as common of a prefix. No, no, it's not. So it does require the full name, but it does curve backwards on itself, which is interesting. Or it's just cal. So this is calc, and then shun. Calculation. Our word calculation, and because that is not hyphenated, it is italicized in the textbook, so we do a triple underline for that to show that we are dealing with italicization. If you just do a double, well, actually, we could just do a double underline like that would work for italicization. Because if you do two strokes like that, then we're dealing with a proper noun. So 2 lines underneath is all you need in order to demonstrate that we're talking about italicization. Okay? Our word calculation is derived from the Latin word calculus, which is really interesting. Is, and then derived is going to be dr. I'm going to guess that that's derived. Let's go ahead and check it out. So derive just requires its dr and then the diphthong. dri. Like so. Is derived, so it is derived from the Latin word calculus. From the Latin. Yep, I don't know if I looked up the word Latin. Let's go check it over here in the dictionary. Oh, and it's curved the other way. It's curved back in on itself, not inside. All right, so let's go ahead and go, which makes sense. So normally it is, if this were just like the word late, then it would be there, like later. But if you're dealing with the curved stroke, which this is called a composite, it's a composite, it's a composite consonant or a consonant blend, a consonantal blend of T and N. And anytime you have a consonantal blend of a T or an N, if it is preceding or if it's following one of the liquids, which would be R or L, then you do have to put the circle vowel on the outside of the term. So this is Latin, and here's where it's a proper noun, so we have to do 2 strokes. Our word calculation is derived from the Latin word, and calculus is our next word. So let's go ahead and check calculus. So there's calculus. Let's see. It is not in the dictionary. So what we're going to have to do is we're going to have to add it. So in order to do calculus, we'll simply use calculation and then just do calcus. Okay? So it'll be the same beginning stroke as calc and then us. Calculus. Okay? Because if we look up any form of calc in the dictionary, that'll tell us if we are working with what would be considered a standardized beginning of the word. And you see that calculate is KL, KAL. You have calculable, calculator, calcium, calcine, calculation, and so on and so forth. And let me go ahead and make sure that I have I need to go to properties, and you should be able to show the cursor. That way, when I'm moving my mouse over any of these positions, you can see the mouse moving. So I can hover over particular selections. So what we'll do is we'll do calculus, and like I said, if a word is not in the dictionary, then I simply add it after the fact. So that means over here. Also, let me make sure, the levels are right around 18, which should be pretty good for the microphone. I think I would prefer to have them up just a hair. So let me go in here, and I'm going to increase this to probably 9. Let's try 10. So there's around 10. We just bumped up a little more. It's a little better. Ordinarily in OBS, you want your microphone to be around -6 as far as what it is peaking at. So that should be good right there. I might even increase the levels just a little bit more. Testing 1 2 3, testing 1 2 3, testing 1 2 3. Good. So there we go. We're sitting around -6. Hopefully we're not picking up too much room noise. And yeah, I might want the mic down just a little bit so it's not too sensitive. And now I'll go back over here and change my microphone level up to, let's try 14 dB. There we go. Testing 1 2 3, testing 1 2 3. There we go. Now we're sitting right about where we need this to be, which is -6 dB. -6 dB is what you want normally for microphones. All right, now let's go ahead and get started. So I can go ahead and minimize OBS. There we go. And we continue on with our work. So like I said, calculus is not in the dictionary, so I will add it. One of the nice things about Gregg Shorthand is you don't have to have a perfectly standardized system for displaying your information or displaying the strokes. You can, oh, come on, there we go. You can use what's called derivation or analogy. Derivation or analogy. So that's what I did in order to create calculus on the fly, so to speak. But I will add it so it's a more standardized form in case anyone needed to look it up. So there's calculus. All right. And we do 2 lines underneath. And now I go ahead and do comma, which means pebble. Which means a pebble. And that's really interesting, isn't it? So calculus, in fact, it's a whole branch of mathematics. It is, it's based on the Latin word for pebble, which is fun. All right, moving on. Shorter ways of counting have been invented. Shorter ways have been invented. So shorter is going to be, well, this is short, and so shorter would just be an R underneath. We go take a look at that. Let's see if that's correct. And that is correct. So short is a standardized prefix, and so therefore it goes above the line of writing, and then the R goes down below. So there we go. Shorter ways of counting have been invented. So in, and then vent, ed maybe. Let's go ahead and check and see if that is invent. See if I'm missing any vowels. That is invent, very good. And then invented would simply take the stroke up a little bit higher. So let's go ahead and take care of that here. We have invented, like so, okay? So there's invented, comma. Shorter ways have been invented, by which many calculations, hold on, many and mean, are those, no, many is just a long stroke, right? Yes, yeah, it's the M in stroke followed by an E. There we go. By which many calculations, comma, which could require long and tedious reckoning, which could and then require long and tedious. Long would be, I think that's long. And tedious is going to be tedious, so maybe it's just this might require a circle vowel. This might require a circle vowel inside. Tedious. Let's go and see if that's tedious. Yep, that's right. So there's tedious, long, and tedious. Reckoning. Now, reckoning is interesting. I think it's probably just going to be reckoning. Let's go ahead and check and see if that is correct. Go over to the dictionary. Reckoning obviously is not going to be a word because it's just a simple dot on the end. But let's go ahead and check reckon. And so reckon does require an R. It requires a circle vowel. So we'll go ahead and add that. Long and tedious reckoning if pebbles were used. Comma, are made at once with very little trouble. Are made at once. Are made at once with very little trouble. With very little, so very is, there we go. I think little is just L-I-T, same as literature, but let's go check. Yep, that is correct. So there we go, very little trouble. And so this would be another example of the BL ending, right? Trub is trouble. Trub. We can confirm that that is the case. Yep. Continuing on. The four great methods are the four great methods are, comma, addition, and for this we do the two dashes to show that this is a proper noun, addition, subtraction. Comma, multiplication, check and see if that is multiplication. This also is going to require an EK shun, so we go, there we go. Multiplication, also a proper noun, so we put the two dashes underneath, comma, and division. And division, I think we had done this before, but I think it's I think that's division. Let's go and check it. and that is correct. Let's go ahead and straighten it up just a little bit. Move this down. There. Okay, and I just realized that the hopefully the website, just looking at the display, looks like the website's going to be in the way just a little bit. So let's go ahead and reposition the website, move it over. There we go. That's a little bit better. Can also move the screen over, or the display. Nice. Okay, so let's go ahead and go back over. And what I'll do is we'll add another page below. And this is going to be Elements of Arithmetic. So E-O-E-O-A. And this is section 2. This is page number 2. All right. So there we go. We save the page and then we go back up to the original page. So we always keep one page below the other so that it can be displayed more readily. All right. So we have multiplication and division. And division is this format here. We simply need to do 2 dashes underneath in order to show that it's a proper noun. Division, of which the last two are only ways of doing several of the first and second, of doing several of the first and second. At once. There we go. All right, so that is the first paragraph, and we read back through. So we drop a paragraph marker. I don't know what the color is going to show up. This might appear as kind of a reddish hue when I display. It'll probably come up as red, and that will mark the beginning of a new paragraph. So it's an arrow. Hold on, let's make the arrow just a little bit sharper, and then we do a highlighter, and that will then display. So now what I do is I take my disappearing highlighter and I read back through the paragraph in order to do our reading practice at the same time. So we do writing practice and then reading practice, okay? Here we go. Addition and subtraction. Those are the two headings. Let's go and make them proper nouns as well. Addition and subtraction. Number 28. There is no process in arithmetic which does not consist entirely in the increase or diminution of numbers. There is then nothing which might not be done with collections of pebbles. Probably at first either these or the fingers were used. Our word calculation is derived from the Latin word calculus, which means a pebble. Shorter ways of counting have been invented, but by which many by which many which could hold on, I'm kind of missing it now. Which would require, which would require, that's why, because it's not could. So we're going to change this to a would right here, which, hold on, I'm blanking. I know that would, if you're talking about, yeah, it is just a D. If you're talking about the actual material would, that is spelled with two dot or two lines or two U-hooks at the beginning. But if you're talking about the word as in I would do something, the linker or the indication, then you just use the D stroke, okay? And then we have require. Let's make that R just a little bit more pronounced. There we go. Which would require long and tedious. So we'll go here. Require long and tedious reckoning if pebbles were used are made at once with very little trouble. The four great methods are addition, the double line underneath to show it's a proper noun, addition, subtraction, multiplication, and division, of which the last two, let me check last, I'm pretty sure it's just LAS, but let's go ahead and check that out. Yes, of which the last, oh, and I just realized I just highlighted a whole bunch of these, so let's go ahead and get rid of that. There we go, grab my correct one, of which the last two are only ways of doing several of the first and second at once. All right, so there's our first paragraph. So now we're going to go and scroll down. Oop. There we go. Now we're going to go to 29. So we have 29. All right. One of the nice things about these old textbooks, as I've said previously, is that all of our paragraphs are numbered. So that helps a lot. So we go 29. There we go. When one number is increased by others, when one number is increased by others, comma, the number which is as large, that should be large. Let's go ahead and check and see if that is the case. Yep, that is the case. The number which is as large as all the numbers, together is called their sum, is called their sum. Notice this, we are dealing with an italicized character, so we do two lines underneath to show that we're dealing with sum. or we're dealing with an italicized word, is called their sum. And then the process of finding, period, the process of finding the sum let's make the PR just a little bigger, of finding the sum of two or more numbers is called addition. Is called addition. Now, addition, notice here it's in all caps, so that's a little trickier. How would we denote that? Probably by doing, we could actually do two of them together. We could do two to show that it's a proper noun, and then maybe an underlined to show that it has special interest, okay? Usually just the two lines underneath would be enough to show that we're dealing with a proper noun for addition. Hey, was it hurt? And plus we make like a little face. It's a little guy with his mouth. All right, so that's addition. And as was said before, speaking of section 1, and as was could be a good phrase. As was, it's an older one, but yeah, he's probably going to use it a lot going forward, so we'll go ahead and create one. This is as was, said before, comma, is denoted, and denoted, it should be, is that not, I don't think that's denote. Let's go ahead and check. I know I used it yesterday, but it's not a word that, yeah, it's not a word that I use that often, so here we go. We go denoted is denoted by placing a cross check cross. It requires the O hook. Between the numbers which are to be added together. And between the numbers which are to be added together, which are to be added together. Yes, that's correct. And that's the end of the next paragraph. So go ahead and drop a paragraph marker here and highlight it so we know that's where we're going to go back to. And we start back at the beginning of 29, which is down here. Okay? 29. When one number is increased by others, the number which is as large as all the numbers together is called their sum. The process of finding the sum is of two or more. So I need to put a more in there. two or more numbers is called addition. And as was said, go ahead and make that just a little bit smaller. As was said before, is denoted by placing a cross, this symbol here, between the numbers which are to be added together. And there we go. So that is that paragraph. And now we continue to our next paragraph. So we have our paragraph marker there. And to move it up here so it's more centered, we go ahead and get started. Suppose it require to find the sum of 1,834. Suppose, I think that's suppose. Let's go ahead and check it. So suppose does not require the S. There we go. Suppose it require it required to find, go check find. To find the sum of 1,834 and 2,799, period. In order to add these numbers, comma, take them to pieces and pieces is going to be P-E-S-E-S probably. Let's go take a look. So there's piece, and then pieces, you simply turn it back in on itself. Like so. Okay, there's pieces. Take them to pieces, comma, dividing each into its units. Dividing each into its units. And dividing, let's see if that's dividing. Dividing each into its units. Each into its units. Unit is E-U. I think that's units, right? Unit does require the second E, so let's go ahead and add that here. Unit. Dividing each into its units, comma, tens. So we go tens, comma, hundreds, comma, thousands, and thousands, and then thousands. Let's go check that. and thousands. Dividing each into its units, tens, hundreds, and thousands, colon. And then, so we then have an example here. So we would say that 1,834 is 1,000. Like so, I believe that's, yes, 1,000. 800. Might need a little bit more room, so let's do it. Let's do it the line below. Actually, we'll do paragraph. Do we want to have this all on the same line or to follow the separation? Let's go ahead and do the paragraph marker here. Paragraph marker, and then we say 1,834 is 1,000, comma, 800, 3 tens, 3 tens. Let me go ahead and check tens, see if that's correct. Oh, interesting. 10 is not in the dictionary. All right, well, that would be end anyway. So 10 should be a TN stroke, just the beginning. 10. So let's go ahead and add 10 to the dictionary. So 10 has been added. Moving forward, 3 tens, which means I need to change it up here. What was that? Yeah, there we go. Tens. So we have to separate it into tens, hundreds, what was it? And thousands, and thousands. There we go. So there are 3 tens and 4. And 4. All right, so that would be the first example, right? For the number 1,834, there would be 1,800, 3 tens, and 4. And then our next line down, so remember lines can always be shown using the paragraph marker or using the paragraph symbol. And now we can go ahead and do 279, 2,799 would then be is, so we use a little is symbol, 2,000. Yep. 2,000. Now remember, for numbers, you can show that by having kind of staggered. So you can stagger 2 symbols in order to show. So this is 2,000. Okay, 2,000. And same thing for 700. Do 700. 9. And see, tens would then go this way. So 9 tens and 9. All right. So there we go. That would be the example for 2,799. So once again, he's talking about the process of showing how you can separate or how you can work with addition. All right. And now we do another paragraph marker. No need to color this paragraph marker, by the way. All right. Oh. 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 Why is that not updating? That is weird. Huh. No wonder. There we go. I was wondering why that wasn't updating. Wow, I just now realized. Okay. Now we should be good. All right. So continuing on, each number is thus broken up into 4 parts is the next paragraph. So we go each number is thus, and thus is that symbol right there is thus. Let's go check that. Yep, that is thus. Each number is thus broken up, and so broken is BRKN, I believe. It could just be BRK with no need for the O vowel. Well, let's go check it. Yep, that is broken. All right. Each number is thus broken up into 4 parts. Let me check up quickly. For some reason, I'm thinking that's oop. Yes, the uses an U hook, not an O hook. There we go. Okay, so then we have parts broken up into 4 parts. This one. All right. If to each part of the first, so here's our sentence. If to each, if to each part of the second U, which is under it, comma. Oh no, hold on. If to each part of the first, there we go. If to each part of the first, you add the part of the second, which is under it, comma, and then put together, and then put together what you get from these additions, what you get from these additions, comma, you will have added, you will have added, new line down. Let's go ahead and add another page below this. So this is Elements of Arithmetic. section 2. And this is page number 3. New page over here, so let's go ahead and fix this while we're at it. So let's go elements of not animation, elements of arithmetic, section 2, page 2. Now we go back over here and we have get from these additions. You will have added what? You will have added 1,834. You will have added 1,834 and 2,799. Period. In the first number are 4 units. In the first number are 4 and this one, units, comma, and in the second 9, and in the second 9, these will, when the numbers are added together, these will, so it's talking about the 4 and the 9, which would be here, right? In the first, in the units place, it's 4, and in the units, it's 9 over in the other side. So they're saying that if you get those numbers, you put them together, then you will end up with the values. So second 9, these will go, make sure my volume's turned down. There we go. Set this on Do Not Disturb. There we go. Nice, nice. All right. Let us proceed. So these will when the numbers are added together, when the numbers are added together, comma, contribute, and contribute is contrib, so this is con t, and then it should be contribu at the end. Let's check and see if that's correct. Contribute. Oh, and I realized that I inadvertently, undo. I inadvertently used the wrong highlighter again. There we go. Okay, so contribute. Let me go ahead and check. Oh, contribute is just a K and then a B. There we go. It will contribute 13 units to the sum. 13 units to the sum. contribute 13 units to the sum. Period. Again, the 3 tens in the first. Again, the 3 tens in the first, and the 9 tens in the second, and the 9 tens in the second will contribute 12 tens to the sum. The 800s in the first, the 800s in the first, and the 700s in the second, will add 1500s to the sum. And the 1000 in the first, with the 2000s in the second, will contribute 3000s to the sum. Will contribute 3000s to the sum. Comma. Therefore, the sum is required. Therefore, the sum required is. Therefore, the sum required is, comma. And then let's go ahead and do another paragraph marker. $3,000 $3,000s, $1,500s, $12,10s, and 13 units. New paragraph. To simplify this result, you must recollect that and then simplify. Simplif. Let's go take a look and see what simplif would be. Yep. So to simplify this result, comma, you must recollect that check must. Yeah, it's the U hook. Always have to remember that one. Curves back and under, like so. You must recollect that, and so recollect is going to be recollect. Recollect. Let's go ahead and check and see if that's correct. Yep, that's recollect. You must recollect that 13 units are 110 and 13 units. Units are 110 and 3 units. Period. And this one also needs to have a paragraph marker there. 12 units are, so we go 12 tens. 12 tens are 102 tens. 102 and 2 tens. Next line, 1500. 1500 are 1,000 and 500. 3,000 are 3,000. 3,000 are 3,000. Next line down. Now collect the numbers on the right-hand side together. Now collect the numbers on the right side. Right-hand side. Right-hand side. So let's do a hyphenated. Right-hand side together. Comma. As was done before. So this is an older textbook, so we use a phrase that you normally don't see, which is as was. As was done before. And this will give a new line over here. And this will give, comma, as the sum of 1,834 and 2,799, comma, the total value of 4 thousands, comma, 6 hundreds, comma, 3 tens, and 3 units. Comma, new paragraph line, which is, now notice he's referencing in the textbook, he has in parentheses, he has a 19. The reason for that, if I'm not mistaken, is you'd have to go back up to paragraph 19, which, going back up, we take a look. He's talking about how positionality, right? Where's 19? Yes. So he's talking about the positionality. So you can then take the names of the letters or the names of the numbers, and then you position them in a row, and their position in the row is going to determine, it's going to determine their name value. Okay, so that's what the 19 stands for. And remember, we are currently in 20. If I scroll back down, we are in paragraph, is it 30? Hold on. Where was that? Just lost my place. There we go. There we go. Coming up, coming up, coming up. He's talking about differences. Scrolling, scrolling, scrolling. Where are we at? Rule 1, place the numbers one under the other. So on and so forth. Come on. Where are we at? 29. Yeah, 29. So that's what he was talking about. So 10 paragraphs before is where he references the idea. What's interesting is that principle of referencing the work in previous, or making reference to the work, that's actually drawn on in Euclidean geometry as well, when you are attempting to solve or to prove that certain propositions are true. Then you will reference previous propositions to help you determine whether something was already proven or not. Okay, so that's what he means here. So when he says, and this gives the sum of 1,834 and 2,799 as 4,000s, 600s, 3 tens, and 3 units, which, according to paragraph 19, would be written as, there we go, which, and then in parentheses, according to paragraph 19, is written as 4,633. Like so. That's the end of the paragraph. New line, and this is actually and this is a new section as well. So what I'm going to do is, in order to practice the reading as well as the writing of Gregg's shorthand, then I have to go back to the beginning of paragraph, go back over here to paragraph 29. There we go. and we start reading through. Oh, undo. Here we go. We're looking for paragraph 29. We're also looking for the paragraph marker, which is here. Okay, so there's our paragraph marker right there. And this is the beginning of 29. When one number is increased by others, the number which is as large as all the numbers together is called the sum. And the process of finding the sum of two or more numbers is called addition. And as was said before, is denoted by placing across between the numbers which are to be added together. There's a new paragraph marker. Suppose it required to find the sum of 1,834 and 2,799, and that should be a true Greggian sentence marker. 2,799 in order to add these numbers, take them to pieces. Dividing each into its units. Tens into its units, tens, hundreds, and thousands. Next paragraph. And that would show that this line of 1,834 is 1,800, 3, 10, and 4. 3 tens should be 800s as well, and 4. And remember, it's the 4 units, 4. And then next paragraph, 2,799 is 2,700s, 700s, 9 tens, and 9, just 9 for the unit. Each number is thus broken up into 4 parts. If to each part of the first is it are added? Is that what it should be? If to each part of the first you add, there we go. If to each part of the first you add the part of the second, which is under it, and then the together, wait. And then put, oh yeah, that's put it, right? And then put, where is it here? And then put together. Oh, it is, okay. And then put together what you get, yeah. What you get from these additions, you will have added 1,834 and 2,799. In the first number are 4 units, and 4, it should actually be, we'll switch over because it's talking about the number, right? are 4 units, and in the second 9. These will, when the numbers are added together, contribute 13 units to the sum. Again, the 3 tens and in the first, and the 9 tens in the second will contribute 12 tens to the sum. The 800s in the first and the 700s in the second will add 1500s to the sum, and the 1000 in the first with the 2000 in the second will contribute 3000s to the sum. Therefore, the sum required is 3000s, 1500s, 12 tens, and 13 units. To simplify this result, you must recollect that, new paragraph, 13 units are 1 10 and 3 units. 12 tens are 102 2 tens. 15 hundreds are 1000 and 5 hundreds. 3000 are 3000. Now collect the numbers. Now collect the number. Wait, what does it say here? Was it numbers? Now collect the numbers. So let's go ahead and make this plural. Now collect the numbers on the right hand side together, as was done before. And this will give as the sum of 1834 and 2799, 4000s, 600s, 3 tens, and 3 units, which is, let's go make this a little clearer, which is, according to paragraph 19, so we need to do just which, according to 19, is written as 4633, all in a row. I will be back shortly. 1 second. Okay, and we are back. So now we've already done the paragraph here ending at 19. So 19, it was written as 4,633. So now we begin our next paragraph. Paragraph 30. The former process written with the signs check and see if that is former. Yep, there's former. The former process written with the signs taken from paragraph 23, written with the signs of, according to paragraph 23, is as follows. And remember, is as can be done with just two S strokes. Is as follows. So if you write them out, then the first value, and for this particular example, I think I probably will do it on a line below, just because it could get a little bit funny if, yeah, I'll have to write this out below. So let's go ahead and do this here. We have 1,834. If we use our symbol of equality, this is equal to 1 times 1,000. Might have to make them a little smaller to make it all fit. Let's see. Maybe half the size? That should work, yeah? So if we go 1,834, this is equal to 1 times 1,000 plus 8 times 100 plus 3 times 10. That's the top line. And then the one below it, we might actually, yeah, we'll do it in the blank space below. So let's go 2,799 is equal to 2 times 100. So you see we have to line these up. Plus 7 times 100 plus 9 times 10. Oh, I forgot a plus 4 over here. Plus 4 for the 4 units. Plus 9 times 10 plus 9. Okay. So now, that looks okay. So we have those units all laid out, and then if we write it out here, therefore, so we jump down a line, go ahead and save the page, and we say, therefore, and for that we're just going to put this here, therefore, and then on the line below would be equal to 1,000. I think we can do this all in one line. 1,834 plus 2,799 is equal to 3 times 1,000 plus 15 times 100 plus 12 times 10 plus 13. Okay, so there we go. That's all laid out on one line. 1,834 plus 2,799 is equal to 3 times 1,000 plus 15 times 100 plus 12 times 10 plus 13. And from that, we can then, let's see, they're doing an equal symbol here below. So we do an equal, and we have, which is equal to, but, actually is what they say. So let's see, 13. But 13, now this is interesting. So they're lining up. Oh, okay, so he's lining up the equal symbols. But 13 is equal to 1 times 10 plus 3. And 12 times 10, so we're going to have to start 12 over here. 12 times 10 is equal to 1 times 100 plus 2 times 10. All right, and then 15 times 100. 15 times 100 is equal to 1 times 1,000 plus 5 times 100. Okay? So then we have to simplify this out. We go down, and, of course, 3 is equal to 1,000, or 3 times 1,000 is equal to 3 times 1,000. All right, so that should be pretty clear, right? But, so that little symbol right there is a but. Therefore, it shows the value that the sum of those two numbers produces this unit, which is 3 times 1,000, 15 times 100. 3 times 1,000, 15 times 100, 12 times 10, and 13. But 13 is 1 times 10 plus 3. 12 times 10 is 1 times 100, and 2 times 10. 15 times 100 is equal to 1 times 1,000, and 5 times 100, and then 3 times 1,000 is 3 times 1,000. So we simplify by simply adding like to like. We add like to like, okay? So we then have a therefore. Therefore, and then we're going to do a new line under here. We go back to numbers. 1,834 plus 2,799 is equal to 4 times 1,000, because we're adding, right? We added the 1 times 1,000 to the 3 times 1,000 to give us 4 times 1,000 plus 4 times 1,000 plus 6 times 100. I'm running out of room. Might have to start a little bit smaller off to the right-hand side. 1,834 plus 2,799 is going to be equal to 4 times 1,000 plus 6 times 100 plus 3 times 10 plus really small a 3 plus 3, which we can then write simply according to, remember it was paragraph 20, I think it was paragraph 19, and if we write that simply, then we can just use column or positionality for our linked counters. So we have 4 followed by a 6, followed by a 3, followed by a 3, for giving us 4,633. There we go. So that would be the whole problem laid out. Okay, very exhaustive, but it definitely shows us the value. Now what I'm going to do is I'm going to create a specialized symbol. So when I change back, I've used this symbol before. I'll use it again. When I change back to regular paragraph, I just use the two dots and the tilde. So now we go back to paragraph 31. We'll use a dot. And here we go. The same process is to be followed in all cases. Is to be followed in all cases. But not at the same length. But not at the same length. I believe that's length. Let's go ahead and check it. Yep, but not at the same length. In order to be able to go through it, in order to be able, right? We can use the phrase, in order to be able to go through it, comma, you must know how to add together the simple numbers. You must know how to add the simple numbers. This can only be done. This can only be done by memory. There's a good friend memory coming in. This can only be done by memory. Period or semicolon. And to help the memory and to actually put those together and to help the memory. And I just realized that I misspelled the C. The C should go the other way. There we go. Section. That way I don't look like I'm completely dyslexic. There we go. And to help the memory, you should make the following table 3 or 4 times yourself. Oh, that's interesting. To help the memory, you should make the following table 3 or 4 times yourself. 3 or 4 times yourself. And I guess that's the table that we're going to be doing. Oh, thank you so much, Mustafa. I just saw your comment. So glad that you're here. All right. So now we go here. And this is the table. Wow. Okay. So he wants us to create that? Draw it out? The use of this tables is as follows. Suppose you want a 8 and 16. Oh, okay, so this would be a table of sums. This isn't a multiplication table. This is a sums table. So every value, every row, and every column, the point at which they intersect would be the summation. Okay? I'm not going to do that. You are welcome to. You are welcome to go ahead and do that table. Seeing as how I already have the numbers memorized as far as what the values are. But just know that if you do have trouble with addition, I'm not in any way suggesting that any of you do, but just know that this table, if you copied it about 3 or 4 times, it would prove useful, okay? Now, what I am going to do is I could screen capture it and add it to my notes. I think I'll do that. I'm going to take the lazy man approach. So let's go up here to screen capture, and we're going to do selection, and I'm going to select this unit here. You guys can't see this, but what I'm doing is, oops, sorry about that. That was very loud. Hopefully that didn't come through the stream. It probably did. I'm sorry. I probably just blew your ears out. I'm going to mute that from now on. So what I'm going to do is I'm going to pull up GIMP. Oh, and I shouldn't, well, let's see here. I'm going to pull up GIMP, and I'm going to run Inkscape as, oh, not, I don't want to move to trash. Where'd it go? Put this back. All right. So I'm going to open going to create a new image. Let me go ahead and show you that part of the screen, okay? So let me go and go back over to, this would be in making Gregg strokes. So, oh, that's the old timer. No wonder. Okay, so I'm going to remove that. Yes. And what I need to do is I need to show GIMP here. Let me go ahead and create a new image first. Hit OK. And we're going to open an image file. I'm going to go in here to my screen shots. And let's do the one that was just today. There we go. All right. So I think I'm pulled up, ready to go. Let's go over here, open up GIMP, share. Okay, so you should be able to see that now. And then I'm also going to open up Inkscape. And all I'm going to do is I'm going to create a vector using this, okay? Using this image. So I have Inkscape pulled up, I have GIMP pulled up, and what I'm going to do is hopefully you guys can see, yeah, I know you can see GIMP. Let me go ahead and make sure I have Inkscape pulled up as well. Let's go ahead and run, where is it? Properties, open up Properties application window, and we're going to do new document, share. All right, so now what I do is I'm first going to be up here in GIMP, make sure I'm showing cursor good so you can see what I'm doing as I move around. I'm going to go in here, and the image, it as you see as I zoom in, it's a little bit blurry, but it should be good enough for my purposes. What I have to do is I have to convert this first into a mono. I'm going to go to mode, and I'm going to go to indexed. Once I'm in indexed mode, I'm going to switch to black and white bits. Okay, so now it's been converted completely into a black and white image. All right, next thing I want to do is I want to go ahead and remove the black background, or the white background. So, which actually means I want to select I want to select only the black pixels. So I zoom in, and I've used Shift-O to select the black pixels, and then I cut the selection, okay? And that's all I need to do. Once I've done that, where I've been able to capture the black pixels, then I go back over. I have it saved in my clipboard now, right? It's a selection, and I can go ahead and paste it as a element in GIMP, in Inkscape. And I'm not liking how blurry it is. I don't know if the tracing would be able to capture that image or not. Let me go ahead, and before I create the vector in Inkscape, I want to go ahead and resize the image in GIMP. So for that, I'm going to go to the image and then scale, and I want to make sure that my interpolation is turned off completely. Make sure that interpolation is turned off completely, and I want to make my width, let's make it 900. All right, so width is 900, height is 825. I'm going to scale the image. So now we bumped up in size pretty significantly. Now what I'm going to do is I'm going to grab the black pixels again, okay, cut the black pixels. Now that's saved in my registry, or my clipboard, and I go ahead and paste the larger image in Inkscape. Now what I want to do is I want to go ahead and in Inkscape, I'm going to go ahead and make this into a vector. All right, and that's pretty good. We do want to smooth the corners. We apply. All right, so now I have, just like with making my, oh, thank you so much, Mustafa. Thank you. Um, just like the, process of creating the Gregg forms, I have created a raster image. I extracted a rasterized image from GIMP, and I turned the rasterized image into a vector. All right, so now I can go ahead and export the vector, and I want it to go as a plain SVG. I'm going to save it in my pictures. Go over here, save it under vector assets, and we save it there. So now we're going to call this table of additions. Table of additions.svg. And this is very, very useful if there's any time that you need a table or a piece of data from an old textbook. If you just take a screenshot, zoom in far enough so that you have a high enough quality image, then you can take a picture, and if it's just black and white text, you can then convert it into a pure black and white image, extract the black pixels, take that rasterized form and export it to Inkscape, and then Inkscape you can then turn it into a vector, and then from a vector you can then export the SVG, which is very nice because then one of the benefits of an SVG is that you can resize the image with no trouble whatsoever. Okay, so that's pretty much it. Okay, so now what I'm going to do is I first want to make sure that, let's see, I can go ahead and close down GIMP because, well, he might have other tables. Hold up. Discard images, discard. I still need to close GIMP though because it uses too much computational process right now. But I'm going to leave Inkscape up and running until I confirm that I have the table saved as a unit. So I'm going to go over here to Zernal, and when I'm in Zernal, I'm going to add an image, and I'm going to see if table of additions. Ooh, it's way too small. Ooh, that's no good. That's right. Let's see, it zooms out. Zernal does funny things with images. There we go. As you see now, it's the proper size, whereas before it wasn't the proper size. So cancel. So now you should be able to see, once I pull up Zernal again, you should be able to see the image of the table of additions, which I'm just going to position right here so that it takes up one column's width. All right, and that should be clear enough. So now I can go back over to, I can close Zernal, or not, I can close Inkscape because I have the image already saved. I'm going to go back over to mathematics, and now you can see that the table has been set up correctly, and the reason why you see the overlap between the two pages is because this, there we go. Hopefully the black edge, the black border has been removed. Let me go back over to Zernal, or to OBS. So yeah, you see that? So now we have the table saved in the notes, and you'll see that the numbers are all reversed. The reason why the numbers are all reversed is because obviously I am showing you Gregg in a reversed order. Can I, that would be nice. Can I invert the table? That's the question. Can I invert the table in Zernal? I don't think so. Is there a view, edit? Can I flip? I'm checking all my different tools. I don't think I can flip the image. tools. No. Ooh, that is tricky. That means that in order to show the value to you correctly, I need to flip the image. So for that, I'm going to go back over to Inkscape. I closed it down prematurely. I'm going to go back to actually GIMP. I'm going to run it as a program again. And I'm not going to worry about showing this to you guys because it's just going to be a matter of toggling the image. Okay, so I'm going to go into GIMP and I'm going to open an existing image. I'm going to open the table of additions and I'm going to make a nice high resolution image. There we go. Once I have the image, I'm then going to, where is it here? I should have flip, right? Tools, image. I need transform. There we go. Flip horizontally. There we go. So now it's been flipped horizontally. Table of additions.svg. We're going to re-export this as flipped.svg. And now I can go ahead and export. Now you guys will be able to see the correct image. So if I go back over here, so I can close down GIMP. I don't need to save the changes, discard the changes. I go back into Zernal. Go ahead and delete the previous image. And I put a new one in. And we want the flipped version. Oh, once again, it gives me the wrong size. So I have to zoom out, try it again. There we go. So now you should be able to see the correct image. Okay, so that is the table of additions in its correct layout. All right. And there we go. Oh, undo, cancel. All right, so that is our table of additions. Okay, so the way it's lined out, now of course you can see both because you're seeing both the Augustus De Morgan textbook, okay, and you're also seeing my notes. All right, so the way it's laid out is thus. So as he said here, thus, or 3 or 4 times yourself. So he's not wrong. It would definitely be worth your time to write out this table, especially if you're learning, to then be able to do addition more readily. The writing of tables like this can be extremely helpful when it comes to learning addition. Okay, or if you have family members, young children who are learning their addition, it can be very helpful to put it in the form of a table such as this. All right, so there we go. That's our table. What it means is that for if you have your columns here and your rows here, in order to find the addition, you simply line up the two, drop down, and where they intersect is the addition. So, for instance, 6 and 2 is 8, 8 and 4 is 12, 8 and 17 would be, or 8 and 7 would be 15, 9 and 9 is 10. Okay? Now so this is definitely something that you want to have memorized. You want to have something like this completely locked away in your mind, where you don't have to consider the table. The table just is something that helps you in the memorization process. Okay? All right? Like so. Okay, so that's our table. Now let's see what he says after that. He then explains it. So what I'm going to do is I'm going to copy the explanation, because remember that not only is this stream a chance to understand arithmetic, but also a chance to practice writing Gregg shorthand. So now I copy the paragraph that follows, the explanation. Okay? Here we go. The use of this table is as follows. The use of this table is as, so remember, is as can be a symbol like that, just two S's put together. The use of this table is as follows. Colon. Suppose you want to find the sum of 8 and 7. Suppose you want to find the sum of 8 and 7. Look in the left-hand column for either of them, okay? So you go look in the left, and by left, I need to check and see if that is LFT. It should be. Could just be LF though. Yes, it is LFT, and there's no need for the vowel. So we can just do LFT for the left. Look in the left hand column. Now column should be it should be column. Let's go ahead and see. It could just be col, C-O-L. Yep, C-O-L-M, correct. Look in the left-hand column for either of them. For either of them, comma, 8, for example. 8 for, and that can actually be a phrase for example. I've used example very often, but I need to confirm how to spell it. Example. Yes. Good, good. Semicolon. And look in the top column for 7. And look in the top column for 7. On the same line as 8 and underneath 7, so on the same line as 8, or you could say the same row, on the same row as 8, comma, and underneath 7, comma, you find 15. You find 15 when, and we'll actually take a look at that table to confirm and to actually see the process. There's some. There we go. So that's the paragraph that follows, which is what we will then read back over. But let's go ahead and drop a paragraph marker to show that we're beginning a new paragraph. Highlight it, and then we'll go back through. And we actually, before we put this back in, come on. There we go. So before we go back, trying to resize the PDF. We zoomed in a little too far, it looks like, huh? Let's zoom out just a hair. It's kind of it's overlapping a little bit, isn't it? So let's go ahead and resize. Let's resize so that it's just capturing the border. And that should be good now. Okay. So let's go ahead and before we go on, and before we look at the example, we need to go ahead and check the previous paragraph. So let me go back above, and we're looking at paragraph number 31. Paragraph 31, okay? The same process. So let's go ahead and grab our little marker here, and there's paragraph 31. No, that's 13 units. Too far. So we're looking for 31. Paragraph 31. Did I forget the paragraph marker? Looking. 4,000. This is 3,000s. Oh, no wonder. I'm on the wrong column. There we are. There's 31. So now let's go ahead and read through. Paragraph 31. The same process is to be followed in all cases, but not at the same length. In order to be able to go through it. In order to be able to go through it. In order to be able to go through it. You must not, you must know how. You must know how to add the simple numbers. You must know how to add the simple numbers. You must know how to add together. Hold on. In order to be able to go through it. In order to be able to go through it, you must know how to add. Oh, did I miss something? Must be able to know how to add together. That's what it is. There we go. So let's rewrite this line here. You must be able to know how to add together the simple numbers. The simple numbers. Period. Here we go. Now is our next line. This can only be done by memory. And to help the memory, you should make the following table 3 or 4 times yourself. And this is the table he is speaking of, okay? This is the table that he's speaking of. So you create a table. It's a 10 by 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, a 10 by 10 table. So there are 100 units or 100 squares total. Most of the time in school, especially later, you would see this as a multiplication table. This is an addition table. Same concept, just with the rules of addition applied, okay? Now, what you do is you line up numbers 1 through 9 on the top, starting on the left-hand side, okay? And then also on the left-hand side, you have numbers 1 through 9 going down through the base. Obviously, there's nothing in the top right-hand corner. That's almost a 0, or you could put an X in its place. Then in what we're going to do is we're going to read through this paragraph that follows, and then we're actually going to navigate the table, okay? Here we go. Is that the? Hold on. Oh. The reason why I keep on zooming in on the PDF is because it uses a slightly different mode of navigation. You just click and drag it around the page, whereas in Zernal, I have to click and drag with my pen, and so I'm constantly zooming in on the PDF instead of just navigating through. There we go. And there it is, the use. Here we go. The use of this table is as follows. Suppose you want to find the sum of 8 and 7. Look in, oh, it looks a little too long. It only needs to be 2 units long. There we go. Look in the left hand column for either of them, 8 for example, and look in the top column for 7. On the same line as 8, we would also say the same row as 8. The same row as 8, and underneath, let me check underneath to see if that is the correct layout for underneath. Yep, that's underneath. And underneath 7, you find 15. The sum, okay? So now let's go ahead and let's try doing that. So we're looking for the sum of 8 and 15, okay? So he said go to the rows first, and we did that. So here's 8, and then we look for 7 in the columns. 8 in the row, 7 in the column. And then we look for it's called the intersection point. It's the intersection point of the two numbers, 7 and 8, giving us 15. Okay, this works for, let's say, 9 and 8 would give us 17. 7 and 7 would give us 14. Now, one of the interesting things, notice that these intersection points, okay, they line up in this orientation. One thing that's fun is look at the diagonals. 1 and 1, 3 2s, 3 3s, 4 4s, 5 5s, 6 6, 6 6s, 7 7s, 8 8s, 9 9s, and then back to 7 10s. It's because 1 2 3 4 5 6 7 8 9 and 10. So there are 10 9s, 9 10s, 8 7s, 8 7s, 7 12s, 6 13s, 5 14s, 4 15s, 3 16s, 2 17s, 1 18, which is pretty interesting, isn't it? Tables like this are always a lot of fun. And you also, if you take a look, you can see all sorts of really interesting patterns when you do this. Like, for instance, if you march across this direction here, you'll see that you are going up by 2s, right? 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. So really fun methodologies. Okay, so with that, we move on to the next paragraph. And I just realized that my camera, it would be blocking off part of the last two elements, huh? Yeah, I just now saw that. Well, that's a bummer. Let's see, I can make my camera just a little smaller. There we go. And then it would show the whole thing. Nice. All right, so let's go ahead and go back in to arithmetic and keep on writing. zoom down the page, and now we're going to do paragraph number 32. Paragraph 32. When this table has been thoroughly committed to memory, when this table has been thoroughly committed to memory. So thorough, what is thorough? It should be, I think it's that. I think that's thoroughly. Let's move it over just a little bit. Put it down the line just a little bit. Put the B. There we go. Has been thoroughly committed to memory. Committed to memory. Committed. That's interesting. Let's see. How would you spell that? Is it just committed? Might be that simple. Yep, there's commit, and then committed would simply extend it out to a D as opposed to just staying as a T. So there is committed. All right? When this table has been thoroughly committed to memory so that you can tell at once the sum of any two numbers. Let's go ahead and add another page below this. Page 4, Art of Memory. Not art. This is Elements of Memory. I guess it's getting close to lunchtime because my brain is starting to go funny. Elements of Arithmetic. This is section 2, page 4. Okay. Go back up. Once this table has been thoroughly committed to memory, I also need to check thoroughly. I don't think I did. So if we check thoroughly, oh, that's right. It's just the dot, or it's just the TH stroke. Once it has been thoroughly committed to memory. All right. So that you can tell at once the sum of any two numbers. So that you can tell at once the sum of any two numbers, the sum of any two numbers, neither of which exceeds 9. Neither, isn't this neither? Neither of which, and of which would be that. Of which. Let's go ahead and check and see if that is correct. Let me check neither. Wrong direction. Wrong direction for neither. So let's go ahead and flip that around. Neither of which exceeds 9, and exceed would be exceed. I think is that exceed? Let's see. Neither of which. I also need to check and make sure that of which is in the dictionary. And it is. Very good. Neither of which. So that was a comma, right? Yes. Neither of which exceeds 9. You should exercise yourself in adding and subtracting two numbers. You should exercise, exercise, exercise. Let's see if that's exercise. Ah, it's just the E, S, and then R. You should exercise yourself in adding and subtracting two numbers. In adding and subtracting. See if that's correct. And subtracting, let's make that just a little longer. So we have subtracting two numbers, one of which is greater than 9 and the other is less. So adding and subtracting two numbers. Yeah, that's a little too long, so we only need to come to the middle. One of which is greater than 9 and the other less. One of which, and there's our of which again, one of which is greater than 9 greater than 9 and the other less, and the other less. Let me check and make sure that less is spelled with an E. Yep, it is. You should write down a great number of such sentences as the following. You should write down a great number of such sentences of such is isn't that such? Let me see. Nope, it goes backwards. Well, bother zooming in too far again. which will exercise you at the same time in addition, and the use of the signs mentioned in number 23. So we have, you should write down a great number of such signs as the following. A great number of such signs of such sentences. So he actually calls those sentences, which makes sense. That's what they are. Even though they're symbolized, they are, in a way, it is a shorthand version. Okay? So you should write down a great number of such sentences as the following. Comma, which will exercise you at the same time, which will exercise you at the same time in addition and in the use of the signs mentioned in paragraph 23. And in the use of the signs mentioned, so we go mentioned in paragraph 23, and that's the end of the sentence right there. Now each of these, we're going to lay them out. We'll copy them. It's good practice for me because it would be backwards. It would be backwards. So I can go ahead and do that below, and we'll do 3 of them per. So we start here on the right-hand side for me, left-hand side for you. We go 12 plus 6 equals 18. Then we have 22 plus 16 equals 28. And then we have 19 plus 8 equals 27. Right? So that would be the first one. And you would just copy them out. So you would fill out the problems and do them ad nauseum. Let's go ahead and fix that up just a little bit. So we'll go 12 over here. So this is 12 plus 6 equals 18. And then we have 22 plus 6 equals 28. And then we have 19 plus 8 equals 27. Okay, so that'd be 1. And then the one below it would be 54 plus 9. 54 plus 9 equals 63. Equals 63. 56. 56 plus 7 equals 63. And then 22. 22 plus 8 equals 30. Okay, and then next one down, etc., etc. So I'm just going to do this final one, and like I said before, the only reason I'm copying these is because it's good practice. It's good practice for me to practice writing the numbers backwards. So 91 91, so 100 minus 99 is 91. 27 minus 8 is 19. And 44 minus 6 is 38. All right, so we've done that. And he was saying that if you practice writing these out, and he calls them sentences, which is really interesting, and that's what they are. They are mathematical sentences. All right? So there we go. That is the addition and subtraction. And then 35 or 33, you take a look at that. So here's our next after the numbers. We go back to paragraph 33. When the last two articles have been thoroughly studied, when the last two articles have been thoroughly studied, and thoroughly, like we said, it was just the E, TH, and then E. Oh, sorry. Bumping into my own microphone. Have been thoroughly studied. Yep. Have been thoroughly studied, so we now go down the page. I need to check studied, because I know study and is studied, understudy, there's study. So I think for this one, because it's already so long, we'll just go ahead and do the S right here for study, and then studied would just have a line under it. Helps to keep it from being too long. When the last two articles have been thoroughly studied, you will be able to find the sum of any numbers by the following process. Okay, comma, you will be able so it's you will be able. Remember, will be able is a nice phrase for us, so let's go check that, see if it's in there. Will be able. Yep. You will be able to find the sum of any numbers. Find the sum of any numbers by the following process. By the following process, which is the same as in 29, which is the same as in 29. And that's the paragraph number, so we drop that there. And that's also the end of the sentence. And then there's a little note here about in this and all other. In this and all of the processes, the student is strongly recommended to look at and follow the first appendix. I'm not going to worry about that. So right now we're just going to write down the rule. Rule 1. Rule 1. So, oh, and this is a new paragraph. So let's go ahead and write that there. So it's 29. Paragraph marker. Highlight it. Now before we do that, we need to go back over and read all of 31. All of 31, right? No, we already did 31, didn't we? 31, we did the table. 32 is what we need to read. Here we go. 32. When this table has been thoroughly committed to memory so that you can tell at once the sum of any two numbers, neither of which exceeds 9, and by 9 I'm going to put a little mark there to show that's 9, neither of which exceeds 9, you should exercise yourself in adding and subtracting two, same thing, I'm going to put a couple lines under to show that that's a number, two numbers, one of which is greater than 9, same thing, greater than 9, and the other less. You should write down a great number of such sentences as the following, which will exercise you, and that L should be a little longer for which will, there we go, which will exercise you at the same time in addition and in the use of the signs mentioned in 23. And then it lays out all the example sentences that you would want to be able to practice. Okay. And then below that is paragraph 33 before we then go on to the rule. So let's go ahead and read that. When the last two articles have been thoroughly studied, you will be able to find the sum of any numbers by the following process, which is the same as in 29. Okay. All right. So now we'll go ahead and keep on going. Rule 1. Rule 1. Place the numbers under one another, units under units, tens under tens, and so on. Place the numbers under one another, comma, units under units, tens under tens, and so on. Period. Number 2. Step number 2. Add together the units of all. add together the units of all, comma, and part the whole number thus obtained into units and tenths, and part the whole, and this is underlined, the whole number thus, I think that's thus, isn't it? Yep. That is thus. Okay, so we have thus, and part the whole number thus obtained. Now, obtain is ob, and then is it obtain for obtain? Let me check. Scroll down. Yes, that is obtain. Thus obtained and part the whole number thus obtained into units and tens. Into units and tens. Period. Thus, let's go ahead and add another page below this. This is going to be page number 5. So this is Elements of Arithmetic, section 2, page number 5. Okay. All right, and let me go back up here, save the page. Oh boy. Glad we're getting, I've got 6 minutes left. I'm glad. I'm feeling it. I'm ready to take a break. Units and tens. Thus, if 85 be the number, comma, if 85 be the number, comma, it's a little too big, part it into 8 tens and 5 units. Part it into 8 tens and 5 units. Semicolon. If 136, if 136 be the number, comma, part it into 13 tens, part it into 13 tens and 6 units. And that was according to paragraph 20. So referencing paragraph 20. Next, number 3. Okay. You know, I think I might need to bump my pen size up a little bit because I'm feeling a little constrained. I'm having to write thicker and thicker, and I don't want to. Here we go. Write down the units of this number. Write down the units of this number under the units of the rest. Under the units of the rest, yep. Under the units of the rest, and keep in memory the number of tens. And keep in memory the number of the tens. Next paragraph. This is number 4. Paragraph 3. So this is number 4. Add together all the numbers in the columns of tens. Add together all the numbers in the columns of tens. All the numbers in the columns of tens, comma, remembering to take in, or carry as it is called, remembering to take in, or is that carry? Carry, I think, just uses a, yeah, just the dot over the top. All right. Or carry, comma, as it is called, as it, oh yeah, and then this is as it is called. The tens which you were told to recollect. The tens which you were told. What is told? Oh, it's just TO, which you were told to recollect. And that's recollect, which is kind of fun. Yep. In 3. All right. So there was our time for right now. I'm going to go ahead and take a break now, get some lunch, and I will be back. I will be back shortly, so thank you so much for joining in. And that was a good session. That was a good session. What was that? Almost 3 pages? I'm not sure exactly how this is laying out as with regards to the De Morgan, but it was a really good copywork practice. So, like I said, the page, or I'm back to doing more standardized copy work in even of something like arithmetic, just until the process of copying the Gregg shorthand becomes really easy. If you're interested in picking up a copy of the book of Augustus De Morgan's book, Elements of Arithmetic, it's down below in the description. There's also information pertaining to Gregg shorthand down there. And if you're interested, you can support me by going to my Patreon or Coffee, and be able to drop a little bit in case this information is useful to you. And without further ado, I'm going to go ahead and go sustain myself. So thank you very much for watching, and hope you have a wonderful rest of your day. See you in a little bit. Bye-bye.